Nexla is a data integration platform that enables AI and data teams to future-proof the deployment of data applications and GenAI applications by enabling components to be flexibly swapped by changing data flows, not hard-coded connections. Today, we're going to look at how Nexla can be used for the Gartner Analytics and BI Bakeoff Challenge to prepare, test, and build a data flow to a GenAI chatbot from our OECD dataset. We're helping customers like DoorDash, Instacart, LinkedIn, American Express, and Clearwater Analytics, who are leaders in their industries, to future-proof their applications and increase data engineering efficiency by up to 10x. Preparing data in Nexla is easy with our data product approach to accessing data from any source. First, we'll show how Nexla makes it easy to add any data in any format. Then, we'll look at how Nexla scans all the metadata available with that data and bundles it into a ready-to-use data product, which makes the analysis easy. Then, we're ready to actually use and analyze the data however we like. In this demo, we'll be training an AI chatbot to help us explore, analyze, and answer business questions about the data with natural language. Let's jump right into Nexla and start by adding our source data. If I go to Integrate, and then a new data flow, we can see all of Nexla's connectors and decide how we want to add our data. We can upload our OECD dataset as a simple CSV, which I exported from the website, but this is a one-time file upload, so it will just be a snapshot of the data at the time of export. Even better is adding the data source as a live API using Nexla's REST API connector that will continue to update with fresh data from OECD as soon as it's updated on their end, providing up to real-time analytics for whatever data we choose to use down the line. One of Nexla's key advantages is the ability to connect to any data system with our universal connectors. It doesn't matter what format or what speed. That means data warehouses, other databases, APIs, streaming, webhooks, even email and SaaS apps are easy to connect to. New connectors in Nexla are easily configured without the need of a hand-coded script, meaning we can add connectors in hours versus days to weeks. Finally, all of our connectors are bidirectional, making it super easy to support reverse ETL use cases as well by making a connector both a source and a destination. Once I configure whichever source I'd like to use, Nexla will scan the source, gather all of the metadata it can, and create a data product, which we call a next set. Next sets are representations of the best available data from the OECD in this case that I can now easily work with and get wherever I need to experiment with different analyses. The data product automatically includes all of the information or metadata needed to support trusting, verifying, and sharing this data with others in your organization. This metadata plays a key role across different personas to build a semantic layer for working with this data. The metadata is presented in this data product screen, but can also be used in the dataset itself. Users with the right access can find and discover this data product for themselves, then use, transform, and prepare the data however they need. With my ready-to-use netset, I can click the Transform button and apply many common and complex transformations in the Transform screen here. Here I can select from Nexla's hundreds of pre-built transformations or code my own to conform my data as needed for wherever I will send it. I can also set validation rules and filters to get specific data from my database. Once I'm ready with the output on the right, I can click Send to Destination. Now that we understand how Nexla works, let's get right into the demo with the OECD dataset for the Gartner Bakeoff. So what we've done is gone ahead and created a few data flows that feed and train an LLM chatbot that we can use to ask questions in natural language about the data and the business questions we're seeking to answer. So we can see we've transformed this detected netset into a netset here that's decoupled from the BigQuery format to actually use as rows and columns format. So here it's all cleaned up, and basically we can see this is the data that we got from the OECD that's cleaned up and put back into a format that we can actually use. This is done with just a few transformations in Nexla that we can go ahead and look at here. So we can do this through custom code, as you can see here, where we're changing the input on the left that we got raw from BigQuery into the rows and columns format on the right. So here's the JSON response. Here's the rows and columns we wanted. And we did this through a custom code transform, which made it very easy and in one step. The best thing is in Nexla is that this transform can now be shared out with everyone else who needs to do the same thing so that they can simply select the transform, apply it, and get the output that they need from our training data in BigQuery or wherever else it lives. Let's go ahead and exit out of that. Go back and look at this transforms net set that's now ready to be used to train the LLM. So I'll go ahead and click to view more on this net set, and any net set that has live data in Nexla that can be queried like an API can be exposed as an API in one click. There's a button here for data feed API on any eligible net set where we can see that Nexla's created an API from this data. So we've taken the live data from the OECD, put it into our own Google BigQuery warehouse, then pulled that back into Nexla and expose it into an API. Very easy to do this in Nexla, very powerful now to have this queryable data using a Nexla API where the key and the API URL are right here given in a curl command. So this is the first part of the setup, is cleaning up this data, getting it ready and queryable to train our LLM in the format that the LLM needs it in. So now this data that we've decoupled from BigQuery and made queryable can be fed into our LLM using this API to train and teach that LLM and enable it to query the data itself in order to find the answers to your natural language questions. The second thing we have to set up in Nexla is a query webhook for that LLM to ask questions, translate those questions, and be able to prompt and query the data set itself. So this requires a few different transformations. In Nexla, it's very easy and simple, and all of it's done in this one data flow. So here we have an incoming webhook that will come from the LLM when you ask it a question. As soon as that webhook takes in that query data as a question, it goes into the first detected net set. So we can see here in the schema that query are question formats that were submitted through the LLM chatbot. Then we need to go ahead and translate that user prompt into a SQL query, and then enrich that by feeding that query into our BigQuery warehouse data set from the OECD, and then get the output back from the SQL output analysis that we then present back in the LLM as natural language from the question. So we can look at a few of these transformations here that we've set up. And here, instead of using custom code as we did for the other transformation, these are a few different Nexla pre-built transformations. So Nexla comes with those pre-built transformations out of the box, and these can be very powerful as point and click transformations to turn this query of questions that are being asked to our LLM chatbot into an actual SQL query and something that we can feed into the BigQuery warehouse to get our answer. So a few of these transformations are here. We're putting in a SQL query here, which is being fed a vectorized version of that query that was given to the model. We've used Nexla to set up each part of this flow from the webhook to the eventual text response back, and all of this happens in seconds as soon as you ask the question. So I'm going to reactivate all of these resources. We can look at the flow again. Now this LLM is only being trained on the OECD data, so there's a lot more enrichment we can do with accompanying documents, more text-based data that we can feed into this same chatbot to train and teach this LLM to answer even better questions. Using Nexla, we're able to set up these data flows and start testing and seeing what kind of responses we can get from this LLM in minutes. You can see each of these steps is only a few transformations. Especially if you know what you're doing, then it can be very, very quick to try these out, swap things in and out, and power our LLM chatbot. So we can see here, simply getting this data into the right format We can feed that into our chatbot, feed other data sets into it, and then set up a flow here to take those queries, translate them back and forth in near real time using Nexla data flows. So we've looked at how Nexla enables you to set up scalable and testable, swappable data flows to power GenAI apps. Let's actually go look at the results and talk a little bit with this chatbot, seeing how that can help us understand and look at this data easier. We're running the ChatGPT 4 Turbo Preview model. And now this model is ready to explore, run that data flow, and use natural language to query and understand the data set to make our job easier of analyzing and understanding the data. So let's try a few queries here. We'll start with something simple. Tell me about the capital income for the United States. All of that happens in just those few seconds as I explained it, and we can see that it's delivered me all of the data and explained it in natural language here. This is really powerful because this is a huge data set with tons of data, and if you don't have a data science degree, then it can be really intimidating to approach and understand this data. I've been able to set this up in only a few minutes to hours in Nexla, and I can test, swap data, and change it as I need to suit my use case. So we get some understandings and trends here, and these are observations coming from the real data that will update in our warehouse as it updates in real time from the OECD, so that I can always get the freshest responses from my GenAI chatbot because of the Nexla data flows. Let's try a more complicated question. Compare the capital income data between the United States and France. So we can imagine in the background now, this is being translated into an understanding of a SQL query. And the SQL query will do something like look at the slice of data that concerns the United States and France. Then that query is being injected. The response gets fed back into the GPT-4 model, which can look at that slice of data and then come up with a real natural language response for us to actually understand. So all of that, again, is happening through the Nexla data flows we just showed and set up. And we're getting the response back in near real time for the OECD data set for this Bakeoff. So now we have the response already. Comparing the capital income data between the United States and France, it shows us how it got arrived at these values and shows us the comparison. So we can see here the capital income in the United States shows a general upward trend, and the capital income in France only has 2 years of data and had a slight increase between those. Then we can see the conclusion, which is the really powerful part of a natural language AI chatbot, showing that the United States has a higher and more dynamically growing capital income compared to France, based on the available data. So not only is it finding the right SQL query to apply and getting that data back, it's also analyzing and bringing those insights to the forefront for us in just a few seconds. Let's try an even more complicated question. What does the capital income data from Australia tell us about income inequality? So this is another level above what we just did twice, which was, so we can go to the highest level of intelligence where there's a lot of gray area in the question that we're asking, a lot of context is needed, and let's see how this performs with only the OECD training set that we've added. So this is one of the business questions from the prompt. What can governments and businesses do to minimize the risk and economic impact of poverty? Where should they focus and what should they prioritize? This is a very abstract question. It doesn't reference the data in any specific way. And let's see how the model responds to something like this based off of just the data it's trained on and looking at, the OECD dataset, and the other general intelligence baked into the GPT-4 model. A question like this would be answered best if there was a lot more context, if we uploaded and trained based on other free text, reports, income inequality data. But let's look at the response we do get. The AI model gives us this response that starts to give us some ideas of government strategies, including education skills training, healthcare, economic policies, social safety nets, infrastructure development, as well as business strategies to reduce income inequality and poverty. saying that both governments and businesses should prioritize actions that have a multiplier effect, and collaboration between the public and private sectors is key. But the main takeaway here is that more context is key for these responses, where we can start to put in all of the business questions and have the AI model at least point to the data we should look at and understand it better than what it does now. That requires more training, more context, which is often difficult to get in here. For example, as I mentioned, adding context to some of those free text poverty reports is very difficult to train an AI with, because that free text needs to be vectorized and then put into the model in some sort of RAG AI data flow. Nexla is built perfectly for that, being able to ingest free text documents very easily, vectorize them, and then add an enriched context to our already existing chatbot. So this chatbot is already very powerful, as you can see, only based on the rows and columns data that we exported from the OECD. But imagine how much better it could get if we added free text context and let the AI learn more about this issue of social inequality and poverty to formulate better and better responses that help us answer and choose what we want to report and show. Nexla can handle the unique data needs for AI, like unstructured documents at any speed, connecting to any LLM. There are generally 3 approaches today to build a generative AI application trained on custom or proprietary data. Each comes with varying degrees of technical lift and associated costs. Vectoring, pre-processing, and then loading that data into vector databases is a data integration challenge. Building reliable and trustworthy models requires richer training data in multiple models with a complete orchestrated solution. With Nexla's converged data platform, building GenAI pipelines and data flows as you saw today quickly is easy, providing all the tools to orchestrate, prepare, transform, and empower real-time context building with any data at any speed, just like we did with the OECD dataset, building a conversational LLM that helped us learn more about the data by asking questions directly. Nexla makes it easy to test and swap out different components, which is key to minimizing rework if you want to swap out one of the components of your GenAI application as you move from prototype to production. That's critical when there are so many unknowns now on what the technical and business implications are of making different commitments at different levels of the GenAI stack. Some components may be great for prototyping, but under legal review, you might have to swap to another component or vendor. Nexla's agility in building GenAI data flows makes that easy, and you never have to worry about committing too far into one GenAI application or another. Today, we approach the OECD data Bakeoff using Nexla to orchestrate, integrate, and prepare the target dataset for an LLM application. The ability to test and implement flows quickly and with agility is critical for GenAI success, and with its converged data platform, Nexla is a perfect fit to train and implement an LLM model, which helped us analyze and learn about the trends in the OECD dataset. Nexla can handle the unique data needs for AI, like unstructured documents, at any speed, connecting to any LLM. Thanks for watching. If you're interested in learning more or seeing a live demo of training an LLM, please stop by our booth during the conference, check out our website, and get in touch to learn more about how Nexla can help future-proof your GenAI projects.